All right, here is chapter 18, and here's a question that's focused on markets and the factors of production, specifically graphing the demand for labor and computing the optimal quantity. So here's the information given. A company operates in a competitive market, selling each unit of output for a price of $20 and paying the market wage of $270 per day for each worker it hires. We're given the following table: the number of workers, the output, the total output from hiring that number of workers, and the marginal product of labor. Now we can find the marginal product of labor. That doesn't have to be given to us. So we can ask, well, what happens when we hire that first worker? Well, going from 0 to 1 will provide us an additional productivity of 20. Now if I hire my next worker, productivity goes from 20 to 39, but the difference there is a marginal product of labor, and that's 19. If I hire that third worker, total product output is 57, but that third worker provides an additional 18, and so on and so forth. Now we want to be able to find the value of the marginal product of labor in this case. And to do so, we need to realize that the value of the marginal product of labor is equal to marginal revenue times marginal product of labor. Now we're given the marginal product of labor here, so that we're okay. Now we need to find what's the marginal revenue. Well, the question is, if I were to produce one more unit, how much money would I get from doing so? Well, for every unit I produce, I can sell it for $20. So my marginal revenue is equal to the price in a competitive market. All right, therefore my value marginal product of labor is equal to the price 20 times my marginal product of labor. And so I have to take each of these numbers and just multiply it by 20. So here my value marginal product is 400. 19 times 20 is 380. 18 times 20, 360. 15 times 20, 300. 12 times 20, 240. All right, there's our value marginal product of labor. And now we want to graph out the demand and wage rate. Well, the demand equation is this. This is our demand. So I just have to graph this out. Now, one thing to note is that in Aplia, and in the book, oftentimes these numbers are a little offset. So this 20 wouldn't be lined up with number 1. It's going to be lined up halfway up between 0 and 1. My personal preference is not to do that for various reasons we'll talk about in class. But they do the same thing when they graph it out, is instead of placing this 400 as the value marginal product of the first worker here, they're going to put it halfway in between. And so there might be slight discrepancies from what you see here to what you see on Aplia, and maybe some differences in the book. But I want to be clear as to why those are the case. So when we hire that first worker provides a value marginal product of 400. When we hire that second worker, the second worker is going to provide the value marginal product of 380. That third worker is going to be at 360. That fourth worker is going to be at 300. And that fifth worker is going to be at 240. And so if you were to graph this out in Aptly, what you notice is the point would be here, 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 and here. Just slightly shifted to the left by half a unit. Now if I connect these dots in a somewhat straight manner, it looks like this. And this is our demand equation. That downward sloping demand curve. Here it's not a straight line, and in real life they may not be, but we have that downward sloping demand equation. And now we need to insert in and identify what the wage is going to be, because that's going to tell us how many workers we should hire. So I put the wage at 270. Because that's the market wage. Then that tells me that here is where I want to hire. This is L star, the optimal number of workers that I should hire. Now, one thing to note is, because we're talking about the number of workers and these are whole individuals, the most I'm going to hire is actually going to be a whole worker. It's really hard to hire a half of person. And so the correct answer is going to be 4. But now let's suppose that rather than be number of workers, suppose it said thousands of workers. well, then it's not that we're going to hire 4,000, but we're going to hire 4,625, 4,000 and change number of workers. So that's one of the reasons why I like to have it on these exact points and not on the midpoint like the applet does. And so that tells us then that the optimal number of workers that this firm would hire would be 4, because if they hire that fifth worker provides an additional value of 240. So that's the benefit of the worker, but it costs 270, and so the benefit is less than the cost, and therefore they wouldn't hire that fifth worker. But the fourth worker, the benefit is 300, which exceeds the cost, so they would hire the fourth worker. So L star in this case, because we're rounding to the nearest whole number, is 4.